Solve 2 to the x equals 7 to the x minus 3. Well, we're trying to solve for x, but x is in the exponent, so we really can't do anything in this form. But maybe we can change it to a logarithm, because we have some super fun logarithm rules that say that log base b of some m to some p is the same as p times log base b of m. Log base b operating on some operand raised to an exponent or a power says we can bring that power down to the front and multiply by that logarithm instead. So that's what we're going to do here. Notice we have x's in both powers, so we're going to apply a log to both sides. You can pick any log you want. You can pick log base 10, log base e. It doesn't really matter. I'm going to do log base 10 because that's what most of my students prefer. Please note, I am not multiplying by log. I'm applying a logarithm. This is an operator. So we would do log of the left-hand side equals log of the right-hand side. Now we're going to use this property right here. I'm going to take that exponent and bring it down. It's going to be multiplied by the log, almost like a coefficient. Okay. So we end up with x times log 2 and x minus 3 times log 7. Notice, parentheses are around x minus 3. That is crucial. You must have those. The parentheses around log 7 and log 2 are not required, but you must have them around x minus 3 because if you drop them, then this says only negative 3 is multiplied by that logarithm. We know that's not true, so we need the parentheses. Now we solve. It might be helpful to compare to a problem we already know how to do. So what if I did x times 4 equals x minus 3 times 11. Again, made this up. Log 2 and log 7 are just numbers, so I pulled numbers out of the air. How would you solve something like this? Well, x times 4 is the same as 4x. And x minus 3 times 11, it might be helpful to think about that as 11 times x minus 3. And then you would distribute, right? So we'd have 4x equals 11x minus 33. We're going to do the same thing over here with our logarithm. If you are more comfortable putting the logs in front, you can do that. This is log 2, which is some number, times x. And this is log 7, which is some number, times x minus 3. So this is log of 2 and log of 7. Log operates on those numbers. Okay, then we distribute right here. So this. So I rewrite the left-hand side. Log of 2 times x is the same as log of 7 times x minus 3 times log 7. Okay, then what do you do over here? Well, you would always get the variables on the same side. So you could do it either order, but I'm going to go ahead and move the x's to the left-hand side. So we would end up with 4x minus 11x equals negative 33. And probably you're screaming at the screen, don't write 4x minus 11x, write negative 7x. And you could. How did you do that? How did you get 4x minus 11x is negative 7x? Well, in your head, you probably did this. 4 minus 11 times x. Every time I ask students how they do that, they tell me they subtract the numbers and they tack the x on at the end. So what you're really doing is you are factoring, right? You can factor an x from both pieces here and subtract the coefficients. I'm not going to simplify this because we need this process. We need this way of thinking about it that we're factoring. So look over here. On this side, I have an x term, and on this side I have an x term. So let's get all the x's together. I'm going to subtract everything. I'm going to move everything, and it doesn't really matter, but I'm going to choose to subtract negative log of 7 times x from both sides. In other words, I'm moving it to the left-hand side. So when I do that, I end up with log of 2 times x minus log of 7 times x equals negative 3 times log 7. In the same way I did over here, I'm going to factor out an x. They both have an x, right? Both have an x. Same way we did here. And I'm going to just subtract the numbers. Log 2 minus log 7. They both have an x. So I'm factoring out the x right here. Okay, then go back to this problem. Well, you could do 4 minus 11, which we said you could do, negative 7. If you had negative 7x equals negative 33, your next step would be to divide both sides by whatever that coefficient of x is, right? And then you'd end up with x equals negative 33 over 4 minus 11, negative 33 over negative 7. So we're going to do the same thing over here. We're going to divide both sides by the coefficient of x. It's just some number. It may not be a number you like, a number you're comfortable with, but it is just a number. Log of 2 minus log of 7. Divide that on both sides. So this cancels. Left-hand side, I get x equals negative 3 times log of 7 over log of 2 minus log of 7. Let's see if that's our answer. Yep, that's what we get. Now I want to point out you could also write this more concisely using our log rules. We have a log rule, as we said earlier, log base b of m to the p equals p times log base b of m, because we can bring this power back and forth, right? Can also bring this coefficient back as a power. So you could really write this, bring this back. This could be like log of 7 to the negative 3. And in the denominator, we have log 2 minus log 7. So we have a rule that says log base b of m minus log base b of n is the same as log base b of m divided by n. So you could also write the bottom as the log base 10, or log of 2 divided by 7. So both are correct.